So significant figures. They're primarily used to help us read a measurement's data. So just read a piece of information and identify how precise the measurement was. Probably something you've never dealt with before up until now. They're not overly difficult, but there are a few rules and a few things to get your head around that make it a little bit tricky when you're identifying significant figures and the number of significant figures. The best process is to practice, and once you practice, you identify a few things. Okay, but there are 3 rules that I like to follow. Now, there's probably other sites that have a few more rules, but I like to follow 3 rules. First of all, most importantly, all non-zero values are significant. So if you see a 1, 2, 3, 4, 5, 6, 7, 8 or a 9, they are all significant values. Clear? All zeros between significant figures are significant. So if I have the number 601, the 0 between the 6 and the 1 is a significant value. Are we clear? And lastly, this is probably where it gets a bit tricky and a bit murky, and I struggle to put this into words. So zeros after a decimal place are significant, providing they are not there to show the magnitude of the number. And what I mean by that is the size. So when I use the word magnitude, and generally if a 0 is not needed to show the magnitude of the number, it's probably significant. So if it's not needed to show the size or the scale of the number. So I'm going to run through here with a couple of examples. I'm hoping this will clarify again. Once you do a couple, you'll probably find that it's a lot easier. So 57.1, how many significant figures? We're just going to go hands in the air. Everyone's going to put your hand up. How many significance do you think we have there? Do we have 1, 2, 3, 4, 5? Good, the answer is 3. 3 non-zero numbers, so that is a nice simple 3. Question B. Example B. We have 6,100. How many significant figures do we have in 6,100? Do we have 1? Do we have 2? Do we have 3? Do we have 4? Do we have 5? The answer is 2. Because the zeros after the 1 are purely there to show that it is in the thousands area. It's to show the magnitude of the number. Are we clear? The 2 non-zero numbers are the significant values. The zeros afterwards are just there to show the size of the number. You don't know whether they're significant or not, so we assume that they are not significant. They don't tell us anything about the precision. 0.000653. Who thinks that is a number with 1 significant figure? 2, 3, 4, 5, 6, 7, 8. Three. Why does that have 3? Because yes, the zeros are after the decimal place, but they are there to show the size of the number. I'm going to give you an example of one in a couple of seconds that isn't like that. How many significant figures in D? Who thinks 1? Who thinks 2? Who thinks 3? Who thinks 4? Who thinks 5? No one got it right. How? Is that decimal, is that 0 there to show the size of the number? Why have they written that? What's the reasoning behind them writing that 0?
Have they rounded it?
They haven't rounded it, because if they were going to round it, they would just make it 4,000, wouldn't they? Have you ever seen in maths your maths teacher write 4,000.0? Ever? So they're not there to show the magnitude of the number. That 0 is there to show what? The precision of the measurement. Are we clear? So the 0 after the decimal place is not there to show the magnitude. It is there to show the precision. This one though, the zeros are after, are they showing the precision or the magnitude? The size of the number? Magnitude. E. What are we thinking?
So if B, for question B, if
Yep.
it had been 0.0, that would be
5, correct.
Down the bottom.
If this, yeah, that one's going to be 5. Okay, same number, but because that 0.0 is there, the scientist or whoever's measuring that has put that 0.0 there to show how precise the measurement is. Are we clear? Question E. 1, 2, 3. Question F. 5. Now, again, very difficult the first time you're doing this to get 100%, and no one in the room got 100% because no one in the room got D right. So don't freak out if you're not getting it correct. It's the first toe in the water moment. Okay, I'm going to give you a few more examples, and then we're going to work through the stuff we have in our book, and we'll come back and have a chat about uncertainty after that.